kinematics, you know that it involves equation of motions that you have been applying technically to some problems. But let's now officially see it in conjunction with differentiation and integration. Now, literally, let's have the equations of motion listed first as a refresher information. Equations of motion. Number 1, V equals U plus AT. Number 2, square V equals square U plus 2AS. Number 3, S equals 1/2. Am I right? S equals what? UT, UT, plus half. Yes. Then S is also what? U plus V over 2T. Am I right?
Yes, sir.
Okay. So this is equation of motion in a straight line. Now, if you are looking at vertical equation of motion, you can still use this formula. And on that note, A becomes G if you are looking at vertical motion. So the same formula, V equals U plus or minus GT. Number 2, V squared equals U squared plus or minus 2GS. S equals UT plus or minus half GT squared. Is that clear for vertical motion? Now, when are you going to use plus? When are you going to use minus? Depends on you. And though it depends on you, but by convention, if the object is moving up, you say it's moving against gravity. So you use negative. So to be V equals U minus GT. V squared equals U squared minus 2GS. S equals UT minus half GT squared. If it is moving up, takes negative G. If it is moving down, plus G. So take note of that. Though some people used to assume that, okay, I'm taking vertical motion upward, vertically upward motion as positive. Then I will not take downward motion as negative. All well and good. But the standard is when it's moving up, you say it's moving against the gravity, you take minus. When it's moving down, it's moving in favor of the gravity, you take it to be positive. Take note of that. Have you written that?
Yes, sir. Yes, sir. Yes, sir.
Okay. Now, let's now look at where integration concept comes in. You know that we define, let me start with speed. We define speed to be what? Change in S over change in T. In other words, speed or velocity is rate of change of distance with respect to time. If it is velocity, the rate of change of displacement with respect to time. So V equals ds dt. And this implies that ds equals v of t dt. Because I'm having dt here means I'm going to integrate v with respect to t. So that means v must be a function of t. So if you take integral of both sides, integral of ds equals integral of vt dt. And that means s, because integral of the s is s, so integral of the s, which is s, gives me that s will now be integral of v dt. Okay, let me say plus constant of integration. But oftentimes, there will be initial condition given. So this integration is expected to be a definite integral, follow from the initial condition that will be given in the question. Do you understand that?
Yes, sir.
And if you want to use the initial condition explicitly, you can say plus c, then you now substitute those values to determine the value of c. No qualms. So this is the formula we are going to use to find distance given the velocity function of the particle, or the speed of the particle or the object, as the case may be. Then we also say that acceleration is rate of change of speed, velocity with respect to time. So that means this can be dv dt. dv equals a dt. So that means a must be a function of time too, because I'll be integrating in respect to time. So take integral of both sides. Integral of dv equals integral of a of t dt. So integrate dv gives v equals integral of a t dt, also plus constant of integration. So if you were given acceleration function and you are asked to find the speed or velocity, this formula will help you with that. Am I communicating?
Yes, sir.
Okay. By similar argument, acceleration can also mean this 2s over the t squared. That is differentiating distance function twice. Differentiating distance function twice will give me acceleration. So take note of that. So if you are given distance function and you are asked to find acceleration, differentiating it twice will amount to finding the acceleration. Hope that is clear.
Yes, sir.
Okay.
Yes, sir.
So take note of that. Now, there are some other fundamental things that one can think of, because there's no way you want to talk about kinematics that you not look at vertical motion of a particle. So because we said a straight line, we did not say horizontal straight line. Do you understand that now?
Yes.
And that is what these ones we take care of. Let me box it with blue. These ones we take care of horizontal straight line motion, while these ones we take care of vertical. So take note of the disparity in them. Now, we can also link this to velocity time graph. And of course, you know that area under a velocity time graph will give you what?
Distance.
Will give you distance. God bless you. It's obvious from here, from this formula, this one. Do you get that now?
So,
Okay. So this is going to be V. So if, for instance, you have this, let's suppose this is the motion of a particular object in a velocity time graph. If you are asked to find the distance covered or distance moved by that particle or object, you need to break this down into modules. Hope I'm communicating.
yes, sir.
Okay.
Yes, sir.
So one of the ways to do it is this. I want to use red to do the partitioning. Can you see that?
Yes,
So this is
yes, sir.
1, 2, 3, 4. So A1 gives us shape of rectangle. A2 gives us shape of triangle. A3 gives us shape of rectangle. And A4, another triangle. Do you understand that now? So partitioning this way, you have made your, who is that? Please, I'm hearing myself again. Partitioning it this way will have afford you to break it down comprehensively, without any issue, so that you won't mix it up that, oh, what shape will I call this one? So this is one way to go. So one can just say that the distance under the curve or the distance moved subject to the area under the curve will be A1 plus A2 plus A3 plus A4. Now, on the other hand, you may want to break it down this way. Let me use blue for that. Let me use blue for that. So I can break it down this way. So in this case now, A1, A2, A3. So the A3 will now give me the shape of a trapezium. Hope I'm communicating.
Sir.
Will give me the shape of trapezium. So A1 is giving me rectangle. A1 plus A2 plus A3. So in this blue, A2 is still triangle. A3 is now trapezium. So that means to find A3, I will use formula for area of trapezium. By the time you do it that way, you are going to get the same value for the distance as the one in red. So take note of that. Is that clear?
Yes, sir.
Okay. Another vital thing that you must take note of is if the movement is below the time, if the movement is below the time axis, what can you say about that? But before we look at that, the movement up here like this one is equivalent to what?
Gradient. Acceleration.
Yes, acceleration. And to determine that, we need to do what? Find the gradient. Very good. What about this?
Acceleration.
The deceleration. Very good. What about this?
No constant no acceleration. No acceleration.
No acceleration. And that's constant what? Speed.
Velocity.
Yes, constant speed or velocity. So you must remember all these concepts. Is that clear?
Yes, sir. Yeah.
Okay. Now, what can you say about if, suppose, okay, let me just extend this. I think this will make sense. What can you say about this? Suppose the graph is like this now. You can see that we have movement below the time axis. So what can you say about that time? What can you say about the event here?
Maybe it's returning back.
Of course, it is. It's returning back, yes. What's the appropriate? What do you say, brother? JC, you are saying something.
I was saying, is it displacement?
Exactly. Exactly. That's the displacement. So that's fine. Okay. So let's see how it goes now. So I've given you fundamentals which you know before. I'm just refreshing your brain. So let's start with simple case. Then probably we'll not graduate it. Number one, there's a diagram for it. So let me try and sketch. So please hold on. Don't be in a hurry. Let me sketch first. Okay. So you can draw now. So this is V, meter per second. This is T in seconds. This is origin. This is 0.7. This is 5. And this is 7. Draw that quickly. Are you done?
Yes, sir.
Okay.
Yes, sir.
So let's have the question. The diagram shows the velocity time graph for the motion. The diagram shows the velocity time graph for the motion of a small stone. Of a small stone, which falls vertically from rest at a point A above the surface. The diagram shows the velocity time graph for the motion of a small stone, which falls vertically from rest at a point A above the surface of liquid in a container. Full stop. The downward velocity of the stone. The downward velocity of the stone t seconds after leaving A. T seconds after leaving A is V meters per second. Full stop. The stone hit the surface of the liquid. The stone hit the surface of the liquid with velocity 7 meters per second. With velocity 7 meters per second. When t equals 0.7. When t equals 0.7. Full stop. Sorry, I just saw something now. There is 1.2 here. It reaches the bottom of the container. It reaches the bottom of the container with velocity 5 meters per second when t equals 1.2. When t equals 1.2. Full stop. Let me run over the statement again. The diagram shows the velocity time graph for the motion of a small stone which falls vertically from rest at a point A above the surface of liquid in a container. Full stop. The downward velocity of the stone t seconds after leaving A is V meters per second. The stone hits the surface of the liquid with velocity 7 meters per second when t equals 0.7. When t equals 0.7. Full stop. It reaches the bottom of the container when velocity 5 meters per second when t equals 1.2. Full stop. Question A. Roman figure 1. Find the height of A above the surface of the liquid. Find the height of A above the surface of the liquid. Roman figure 2. Find the depth of liquid in the container. Find the depth of the liquid in the container. Question B. Find the deceleration of the stone. Find the deceleration of the stone while it is moving in the liquid. Find the deceleration of the stone while it is moving in the liquid. Question C. Given that the resistance to motion of the stone, while it is moving in the liquid has magnitude 0.7 Newton. Resistance to motion has magnitude 0.7 Newton, comma, find the mass of the stone. Find the mass of the stone. Full stop. Solve that. Let me see how you are going to fare. But before you do that, it will be fine if you can identify where A is. From the statement so far, where will A be?
Ideal region.
Read the question very well. Okay, let's ask other people. Ibukun said at the origin. Abolaji, do you agree with that?
Make the maximum point.
Jason, do you agree with that? Which of them do you agree with? Abolaji or Ibukun?
I think Ibukun.
You pinch your tent with Ibukun?
Yes, sir.
That's fine. So, you are wrong. You are supposed to pinch your tent with Abolaji. Abolaji is right. At the maximum point. Read the question carefully. It is, if you look at it from the beginning, you will think the origin should be A. Let's look at where it's what the stone hits the surface of the liquid. The surface of the liquid with velocity 7 meters per second when t is 0.7. When t is 0.7, can you see it? So that means moving up. You were told another thing you need to note from the beginning. The diagram shows the velocity time graph of the motion, for the motion of a small stone, which falls vertically from rest at a point A. And it now hits the surface of the liquid. So where it is coming from in the surface, we are told is from rest. But that information is not in the diagram. Hope I'm communicating. Let's assume that this is the container. You now have the liquid in the container here. This is the level of the. Do you get that now? So the object is now coming down and hits the surface of this the water here inside the container. That's what the image printed here. Hope I'm communicating.
Yes, sir.
So this is A. This is A. So you can now continue now. Are you making progress?
Yes, sir.
Question A, Roman figure 1 says you should find what? Height.
Height of A.
So what do you do to get that?
I need you find the area of the triangle.
Which of the triangles? We have 3 triangles there.
OA. Then
Okay.
at point 0.7.
And now, wait. In that case, don't put yourself in tight corner. Try and label them. You can call this place B. Are you with me? Call this place
Yes,
C. And call this place D. So that will make it easy now. So consider triangle OAB. So that will afford you to get the height A. That's good. So consider triangle OAB. That's fine. You should be through with Roman figure 1 and 2 of question A.
I have gotten an answer for the depth of liquid inside container.
Let's look at Roman figure 1 and Roman figure 2 first. The height. Wait, the height. Okay, A, which is the height? That's AB now. Equals, yes. What do you say you get?
2.45.
2.45. 2.45. What's the unit?
Meters.
Okay, let's wait for others to give us their own.
So that's what I got to 2.45.
Okay, Jason, what do you get?
2.45 meters.
That's correct. Okay, what about the depth? Who is through with the depth?
I got 6.11 meters.
That's Abolaji 6.11. Okay, hold on. Let's wait for others. That's Roman figure 2. Depth. Now, did you pay attention to the question?
So I got 0.5.
Wait. Abolaji, what do you say you get again?
6.11.
6.11. Okay. Ibukun?
0.5.
Okay. Jason.
I'm still solving.
Okay, let's wait for Jason. Jason, don't waste our time. You never lost your time.
Yes, sir. I'm coming.
Where are you
Don't
going?
change my answer. Don't change my answer.
Who?
I want to change my answer.
Who? Ibukun, I mean, Apology.
Me. Yes, sir.
Why do you want to change it?
I made a mistake somewhere.
Okay, you are changing it to what now? You see? What do you say?
4.75.
4.75. Okay. Jason,
So,
I don't understand what you are doing. Both of you are wrong. Abolaji, even the one you change to, you are wrong.
sir, can I change my answer?
So
3.0.
3.0 is correct.
What's good?
I gave you this diagram, the one in blue, for you to see that this is the image the question is trying to give into your head there. What you have on the velocity time graph is the motion. So the area under the curve, is the depth. Am I communicating?
Yes, sir.
Area under the curve is the depth. And what is the curve that we are talking about? Area of A, B, C, D, which is trapezium. Am I communicating?
Yes, sir. Yes, sir.
Which is the trapezium. Because if you look at it, the question says the stone hit the surface of the liquid at A. The surface of the liquid at A. Am I communicating?
Yes, sir.
Yes. So you find the area of the trapezium A, B, C, D. But yeah, do that, both of you.
So I got 3.
Exactly. Okay. Question B. You have to find the deceleration. Yes.
I got deceleration to be 4.0 meter per second square.
Okay, let's wait for others. You are right anyway, because I'm looking at our time. So deceleration.
I may go -4.
Yes, you are correct. The negative indicates it is deceleration. So you now say deceleration is 4 meter per square second. So you are correct. Forgetting negative, that shows it is actually deceleration. And what part is the deceleration in the diagram?
From A to B.
From A to to D. Very good. From A to D. So you just find the slope or gradient, because the distance here will be 1.2 minus 0.7. Then the distance here will be 7 minus 5. So change in Y over change in S. Because it's deceleration, I'm supposed to say 5 minus 7 or 0.5 minus 1.2. I mean, what am I writing here? Minus 0.7. 1.2 minus 0.7. But this one should be 5 minus, let me correct that. It should be 5 minus 7 because it's a negative slope. It's a negative slope. 5 minus 7. So that's what will give you minus 4, which means deceleration. Correct? Okay? Question C. What does question C say we should do? Given that resistance is 0.7, you should find what? The mass. The mass. The mass of the stone.
So I want to solve the question. Are we going to use minus 4 or 4?
Okay, that's a very good question. Who want to answer that question?
You use minus 4.
You use 4.
I used minus.
You use minus? What do you say?
Minus 4.
Okay, let's see. So if you use minus 4, what do you now get?
0.525.
That's why you miss it. You are supposed to get 0.05. Now, this is the stone here. The weight we have vertically downwards, isn't it? mg. Am I right?
Yes, sir.
You have the normal reaction, isn't it?
Yes, sir.
So normal reaction minus weight equals ma. Sorry. This is FR, not normal reaction. This is FR. You get that? According to the question, that there's a resistance to the motion, and the motion has been vertical motion. So this is the net force acting on it. And we have been given the, what is it called? The resistance to motion. Isn't it?
Yes, sir. Yes, sir.
So FR equals mg plus ma. So that will now give us what? M equals FR over G plus A. But our A is the deceleration, which is going to be positive we are going to use now. Hope I'm communicating.
Yes. Yes, sir.
So that will be 0.7 over 10 plus plus 4. Yes, 0.7 over 14.
0.05.
0.05 kilogram. So you can see it's very small. So that's the end of today's class. See you on Sunday.
Okay, sir.
Have you copied that?